if future you is a different person, then think about what would you need to look at this code with no context and understand what's going on, and also just be able to make it just work. Like it shouldn't be, it shouldn't be using a full file path where the file can just move around. And it shouldn't be a system that like we have a free trial on, but we're not going to have it in 5 years. Like just all these things. It's a really helpful lens for these different kinds of considerations. Hi, everybody, and welcome back to Saturdata, where we teach as much as we learn. And in this episode, we're going to talk all about what it means to write good, clean, maintainable code in data with the best tools available. And I think, Sam, this is a journey that you had been on for a long time. So you want to tell people about it?
Yeah, I would assume that this is a journey that all of us have been on at some point. It's just information I'm willing to maybe be vulnerable in a public space and talk about how I once wrote shitty code. And even now, sometimes I might write bad code. I'm not saying that every day I write good code or I wake up just writing good code every day. It's usually most of the times not actually how this happens. But what I wanted to talk about a little bit here at the beginning of this episode was spaghetti code. And, earlier in my career, I thought, and like, what is spaghetti code? I guess like let's put like a definition around this too. Spaghetti code is code that it works on my machine and it works specifically with this data set. And this data set has to have these columns and they have to be this type, right? Like spaghetti code just means it's brittle. And if you change anything about the input data or the input operating system, then your entire program just breaks. And you have to go change code to make it work now on this new one. Like that's what it means to have spaghetti code. You're just constantly changing to keep up with wherever the code exists and whatever the inputs are. And so when we talk about spaghetti code, usually it looks like lack of functions. Things are just kind of thrown in, just running sequentially through the program, and then the program exits at the very end, or it usually doesn't make it to the very end because usually it breaks before then, right? But it's no logging, it's no error handling. That's kind of what I would think spaghetti code is. I don't know if you define it any differently.
I really like that. I think it's also resonates with the metaphor because spaghetti is very brittle and you can break it easily. What I would add on to that is that spaghetti code outside of data specifically is more about just generally bad practices. So like it's not maintainable, it's not readable. Someone else looks at it, they're going to have a lot of questions. It's maybe not very well commented or well structured. Maybe there's duplicate functionality. Basically just like all the stuff they told you not to do, you did. And yeah, I think the added layer on top of that is more what you talked about with like very imperative steps, and it only works on one data set for one day, for one time, not accounting for like edge cases and weird values. So like there's spaghetti code in general, and then like your data specific version of it. But like infra engineers are not writing that type of spaghetti code. Hopefully they're writing good code, but they might be writing another type of spaghetti code.
There's a different kind of spaghetti code for software engineers. You're right.
Yeah,
DevOps.
like all the different pasta shapes, there's like different kinds of spaghetti code.
There's like ravioli spaghetti code, and there's tortellini spaghetti code.
Yeah, I go for the filled pastas myself. I think those are fabulous. For those who have ever been to my apartment, I have like a poster of all the pasta shapes in my kitchen. So I'm a big fan.
I need to get one of these.
I'll send it to you. I'll share it with the listeners after this.
But one thing I wanted to address about the spaghetti code phenomenon, if we want to call it that, what is that? It's raining meatballs? That's what I'm thinking about, that movie?
It's Cloudy with a Chance of Meatballs.
Cloudy with a Chance of Meatballs? That's what it was. Anyway, the spaghetti code phenomenon is that I started looking for ways to like not write bad code. Like the first step to fixing a problem is knowing you have a problem. And I knew I had a problem at some point in my career. I was like, I write bad code. And like just being able to admit to yourself that you don't write the best code is like already a step in the right direction. Kind of like, I don't know, it's a little like rehab session right now. But like once you get past that point of admitting that like, okay, my code sucks, then you move on to like, okay, how can I get better? And I noticed myself in this spot of like, I kept asking for people like, this code was great. How did you even know to write that? How did you know to format it like that? And the responses I always got for that were like, practice. And I was like, that's bullshit. Yeah. These aren't real answers. Like I need, like, tell me how to write better code. And like every time I just kept getting met with like, just write more code. And I was like, what do you, like, I don't understand, until I got thrown into a job where I had to write code. and I had to write a lot of code, and the code had to work, and the code was supporting an enterprise application, and I was pulling data in every day, all the time, like so many different pieces of this, and that's when I learned like what spaghetti code is and like how to not write spaghetti code, and it really was trial by fire. Like you can read as many, I don't know, you can read it. Read like several Python books at this point. I feel like you can read the material and you can practice and you can do things, but none of that really compares to when in you're in it and you have to write code that works, because otherwise you're getting called at 2-3 in the morning because your code broke. That's when you learn like this is what I need to be doing. Then you pick up some bad practices too, like with like try and accept clauses, and you start doing like accepts that catch everything instead of like catching specific errors. So there's even like
Mhm.
things once you get past spaghetti code that we have to work on. But for anyone out there that's like, my code is bad and I want to write better code, I'm unfortunately going to have to give you the same answer. Like, just write more code, but write like end to end, like write something from like beginning to end. Because I think whenever you just pick like a piece, like your Kaggle, like, what is this? Yeah, Grandmasters, the whatever the data competition things that we have, the Kaggle site. Yeah, I feel like those are very good to like learn a topic, but they're not good to learn like clean code practices. Because you're
Yeah.
often just given a data set and then being like, okay, now go like do the thing, right? And a big part of what you need to be able to do in data, whether it's engineering, science, or analytics, is handle different scenarios that might get thrown at you. And spaghetti code is not going to do that. And so the way you can do that is by really practicing like data ingestion and maybe even like throwing in some edge cases and seeing how your code works around that. But it's like you just got to build important code. Maybe that's the important, like the thing here is like you have to build code that matters, not code that is just play code.
I agree. And I think so much of what you said in there resonated with probably everybody who's ever worked in this field. Because we all, like you said, we all go through this journey. And there's just such a big theme that's emerging from this whole season, especially with our auxiliary data skills, which is that if you want to be successful, you need to be good at an end-to-end process that has business
Mhm.
impact and is really important, because there's nothing like that 3 a.m. page to motivate you to do a good job. Salary's fine, but the on-call rotation is the real motivator. And you just have these two different mindsets of like executing on objectives to avoid on call
Yeah.
versus exploring and having fun and playing with a fun data set. And it's just such a different mode. And so like connecting these pieces and just making it just work, that is what makes you the senior engineer, because you are end to end providing impact that's reliable by yourself versus like the notebook data scientist who could be really smart, could have 3 PhDs, but if all they know how to do is make a pretty chart in a notebook, that is not what they're being paid to do.
And it could be a very pretty chart. It could be great and
Yeah.
people could love that chart, but I need to see that chart with tomorrow's data, and tomorrow's data has a hyphen where it needed a space, and all of a sudden the code doesn't work anymore.
I'm imagining like the impossible stakeholder request of like, I need tomorrow's data today.
Yeah. And today our main topic of interest is, like Shiv said at the beginning, talking about how to write good code, but also with the right tools, right? And there's a lot of tools underneath that you could be using as the right tool, or you might think is the right tool. So we wanted to cover some of those today. And what were some of those going to be?
Yeah, so my shirt's kind of foreshadowing for this episode. And the tools that we're going to kind of highlight today are the classic pandas, maybe some of the problems that pandas holds, and then the emerging tools of the new generation of data analysis and data processing that have really kind of solved those problems in very different ways. So the tools that we're going to talk about as part of the new data revolution are tools like polars, tools like DuckDB, and tools like PyArrow. We'll also briefly mention some other tools that at time of recording just came out. So we'll touch on those a little bit. Obviously, they're very new and we haven't explored them super fully yet, but we definitely wanted to include them as part of these like emerging patterns that we're seeing in how people process data. And so, Sam, what are some of the problems that people run into on pandas? What is pandas, to kind of start us off and give us context of like how did all these new tools emerge and what problems are they solving?
So Pandas was created to solve the issue of representing vectors and arrays and rows and columns in Python in a way that was not terrible, in a way that like people could look at it and understand, look at the results, right, and understand, oh, these are the rows, these are the columns, these are the values, right? It was really meant to, and we should have Wes McKinney on to talk about what it was meant to do in the beginning, right? If we really wanted to know. But in my experience, right, Pandas was meant to make data analysis in Python easier, especially coming from some other languages, right? I think before Pandas, Python wasn't really known at all to be like a data analysis language, right? It was more of a programming language. Pandas really started to turn the tide on what Python could do from a data analysis perspective. Before then, you might have tools like R, like SAS, or just SQL Server, SQL code, ANSI SQL code, PL SQL files running in Exadata or whatever it is, right? You have a lot of other tools, disparate tools that could be used for data analysis. Python really kind of brought us all into one spot. I mean, there's still people that use R, SAS, and PL SQL and all these things, but really, like Python gave a lot of people a common language to work with data and also build systems. And that's part of it too, is people were building systems in Python. People can now analyze data in Python. So you get this like less proliferation of languages and things that you have to know. If you can just know Python to work with the data, then that's your opportunity. So I think that's really where Pandas came from. And of course, we're going to talk about some of the issues that you run into with Pandas, but at the same time, we have to remember that before Pandas, there was nothing, right? So Pandas was the 0 to 1. And so even if we talk about single threadedness, row-based analytics, like all these different things that with Pandas now cause headaches, cause things that take more time, people had no other option in Python before that. But like really, Wes opened up a door to a lot of research that people maybe wouldn't even thought about or would have, but it maybe would have taken more time, maybe would look differently, right? You can really say that Pandas changed the tide on a lot of things for data and analytics in Python. So I just rambled for a little while, but what do you think on all of this?
Yeah, I think that that's exactly how it happened. That's the story here. This is what so often happens in at work too, where you go from 0 to 1 and you have something and you're so happy that you have it. And then over time, you start to hit limitations because you're working at an unprecedented scale, you're doing new things. And that's where the kind of friction comes in. And so my entire approach to critical thinking is like, because I criticize something doesn't mean I hate it. It kind of means that I love it. Because if I hated it, I would just abandon it altogether. But if you're criticizing something in a constructive way, it's because you care and because you care about the community around it. So like I might criticize my favorite film. Nothing is perfect, but I still love it. And so when we talk about what are the problems with pandas, we're not trying to say pandas is terrible and no one should ever use it and it serves no purpose. We're saying we love pandas. We grew up on pandas. Now, what does the next stage of evolution for the data world look like with this kind of positive, constructive criticism lens? And so, with all that said, all our pandas disclaimers, don't cancel us, pandas. With all those disclaimers said, I think you touched a little bit on some of the problems that people have encountered with pandas at scale. So, I'll go into it a little bit deeper here. You mentioned single threadedness. So, for people who aren't super familiar with hardware, God knows I'm not, um, computer threads are what runs tasks. So single threaded means you can really only run one like low level task at a time. And multi-threaded means that you can work on different physical parts of the hardware to do more things in the same time. So if you've seen things like Threadpool Executor, which we've talked about a little bit on the podcast before, that is literally running on multiple physical threads of your computer. So that's kind of cool to think about. Hardware engineers out there, hats off to you. I think you doing stuff in real life is really cool. I do things on computers only. So you have single threaded limitations. And I want to talk a little bit about how data is stored. So Sam mentioned row-based storage. That means that when you're indexing on pandas with like iloc and loc types of functions, you are actually like reading the entire row of a data frame. Let's imagine like a two-dimensional data frame here, like an Excel table, spreadsheet type of thing. You are reading the entire row, pulling that into memory of whatever loop you're running, whatever function you're performing, and then grabbing like a cell or a group of cells or a filtered set of cells from that row of the data. And this is really inefficient for a lot of reasons that we don't need to get too deep into right now, but let's just say storing by columns is way better. And we're going to see how columns and row groups come into play a little bit later. That's when we'll dive more into it. So far we have single threadedness and we have row-based storage and row-based like kind of retrieval, I guess is what I'm really talking about. The last thing I want to touch on is how the actual data types are stored. And something that a PM at my last company taught me is that Pandas data can expand up to 10 times in memory because of the way the default data types are stored. So, for example, if I have like a column that contains the values 1, 2, 3, just regular integer values, that may be stored as an int 64, which is an integer with 64 bytes. Like basically imagine the biggest way to store an integer, even though the integer is small, it's not signed, meaning like it's not, we don't have different negative and positive values. We literally just have positive integers. We are storing it in the most inefficient way possible for that data. Sometimes it even gets stored as a string in certain cases, right? So like you have the most inconvenient way to store things. Imagine your annoying little sibling who like there's an entire box of, I don't know, like oranges in your fridge, and they leave like one little sliver of an orange inside this giant box and put it back in the fridge. That is like literally what Pandas is doing all the time. So it's just taking up so much space for literally no reason. And so because of these kind of inefficiencies and the kind of quick and dirty nature of exploratory notebooks, all of us have just been building the most inefficient tables for our like Titanic classification analysis or whatever. And so I think that's the biggest one that stands out to me.
I think that's a great point. Yeah, I think statically typed languages like Rust, for example, are really great when you look at, I mean, this comes from Java and all these other languages too. You look at something and you see it's defined as a U8 and you're like, okay, great. Like it even helps a developer like get an understanding of what that object is supposed to be, right? Because if you just say like int, okay, this could be a lot of things. But if it's specifically defined as like an U8, it's like, okay, there's like a very limited range of what numbers this can be. Therefore, I have certain expectations of what this column will do, right? And things like that.
Mhm.
So, yeah, that's a really good point, too.
Yeah, I like that. There's a lot of intentionality with data types like that. And that's what we need to do in data is we need to be more intentional about our work rather than just like pull it in and let pandas do whatever it wants. We should be more specific about like, okay, I understand how all these data types work. I'm intentionally assigning these data types and I'm going to really just write my code in a very intentional and like non-spaghettified kind of way. That's really what this whole episode is about. So we know we love one-line fixes on this podcast, like we had in the visualization episode that we did, where we have this one Seaborn function that makes all your ugly matplotlib charts look a little bit nicer. I think, Sam, you also had a really nice kind of one-line bolt-on fix for people who just want to maybe make an entire script better in like a second. Tell us a little bit about that. How can we fix our pandas in one line?
Yeah. So, Wes McKinney didn't stop at Pandas. Wes McKinney kept going, and then went on to Voltron Data. And during his time, I think it was during his time at Voltron Data, come around and helped co-found slash found slash I think, I mean, I don't know if he had other, I'm sure he had other people working on it with him. It was PyArrow, and PyArrow is the best way to do this one line bolt on change. So I won't get too deep into what PyArrow is necessarily, but as you can tell, it's based off of Apache Arrow, which is just a columnar memory format. So it goes from row based, like we're talking about with pandas, to columnar memory format, which we have with Apache Arrow, which is much more efficient, mostly from the lens of compression. And that's where column based gets it. So, Parquet. Parquet is column based. And the way Parquet compresses is by putting all the same values together and then just having one value represent a row of like a million values that are all the same value, right? If they're ordered correctly. So that's another where like partitioning comes into play. Columnar memory formats. Also for Apache Arrow, you have zero copy reads, which is really, really great, meaning you can read the data in place. You don't have to make a separate copy of the data to then be able to read the data. You can just read the data from where it lies.
Mm.
Right. And that makes things a lot more efficient in Arrow and in this columnar memory format. And then faster IO too. So for this specific bolt-on, whenever you're doing like pd.read CSV, all you have to do is define the engine to be PyArrow and the D-type backend to be PyArrow, right? And it's in the same place that you're reading the CSV. From then on, you'll have the engine working with you and helping you kind of run operations faster, right? I think you can actually, I forget where it is now, if we can actually define the pandas to be the PyArrow outside of the read CSV, but actually when we load it in, if there's a different package we load in. I forget that piece of it.
Oh, well, tell
No.
us tell us in the comments if you're able to just set every single operation to use PyArrow rather than just a specific read function. Let us know.
But that is one place we wanted to hit on is the bolt-on, because what it does is it means you don't have to reformat any of your code. You don't have to refactor any of your code. You don't have to change anything right about the API calls, right? The API calls to pandas are all still exactly the same. That's the main benefit of this, which means you save yourself a lot of time. Just add on some code into the same lines, and then it'll run 2-3 times faster, more efficient, better memory usage, et cetera, right? All the benefits we'd expect from PyArrow without having to change any of your code. Most things work without problem. There might be some advanced things that work or don't work, and then also you have to keep an eye out for your object types, like your data types, because the data type might not be a seamless conversion. So you have to check those out too. Any additional comments on that?
I think that was really great. I think, again, emerging theme here is that like data work is really defined by the interface that you use. And a lot of us know the interface more than we know what the work actually is that the interface is doing. So that's what we're here to do, is kind of uncover that. And yes, those pesky object data types, that's what I was talking about earlier with the storing things in the most inefficient way possible. If you're storing the string 0 as an object data type, like fix yourself, please. That's a terrible way of doing things. I think we wanted to touch on another bolt-on that Sam actually just told me about, which is the Rapids cuDF. I don't know if this is being pronounced in a way like cuDF or something. I don't know. Rapids cuDF for NVIDIA GPU accelerated data frames. And this is kind of another bolt-on where instead of just using the PyArrow engine, you're actually now running your code on NVIDIA GPUs for like basically just super powered, super fast code that just works differently. So, Sam, how does that work?
Yeah, so a lot of our machines now are being built with GPUs, and especially, I mean, NVIDIA, right, as a company, they're taking off their stock price, just going up and up every day. It looks good in my Fidelity portfolio. And people that work in NVIDIA, man, good for them. But really,
Good
what's
for them.
going on here is you're leveraging the GPUs that are involved in your machine. And what are GPUs used for anyway? GPUs are normally used for like gaming, right? They're very important for people that game. People that game want like the best GPU possible. And I'm not a gamer, but when I started getting the GPUs was when the rest of us started getting GPUs was LLMs, right? LLMs
Yeah.
use GPUs to run. And I've been talking to a lot of people around me about, I want to build my own like at home LLM. And so I've had to learn a lot about GPUs in that time and like what that means. But that's essentially what's going on is with all this like AI push and all your devices want to be AI enabled now, GPUs are getting more and more valuable. And that is where GPUs come into play. And that's where this could be really beneficial is if you have a device, if you upgrade it to the Mac M. Actually, I don't know if this will work on Macs, given that it's CUDA. I don't think it would. I think it's just NVIDIA, so I think it would just be Windows. But I'd have to check on that too. Just based on the
Mm.
naming, it makes me think that it's only NVIDIA. Anyway, moving forward. If you have that, then this would be a really, really great way to just, again, one line bolt on, change the package from Pandas to cuDF, and then everything should work exactly the same. There's going to be a couple issues, right? I'll say 99% similarities here. But one of the benefits of this is even faster than the PyArrow bolt-on, right? Because GPUs are wicked, and for a lot of the operations that are GPU eligible, we'll call it, right? They're going to run 10 times faster than the PyArrow bolt-on, right? So you've now 2 or 3x your code by the PyArrow bolt-on. Now you've 10x your code with the cuDF. So we're saving so much time. And if you have a compatible machine, compatible hardware, then this would be something really, really wise to kind of take a step and look into and start learning about, because it also opens the door for learning about GPUs in general. What else would you add just based on what we talked about before this meeting?
Totally. Yeah. Just good engineering skills to be learned here. And also, it's kind of fun and satisfying when line go up fast. So, it's probably a project that you'll actually finish. God knows a lot of us start stuff and we don't finish it.
What do
Um,
you mean? I don't have
so,
70 abandoned file paths on my computer.
you don't have like 70 private GitHub repos. I realized I had a
Yeah.
project on my resume before I got my most recent job. I had a project on my resume that I started and never finished in like 2022 or something. And it looks like I've been working on it for like 4 years, but I have not been working on it for 4 years.
You're like, no, it was great. It was graveyarded, but it's still there if you want to go look at it.
Yeah, for folks who are interested, Andrei Karpathy, who was one of the cool founders of OpenAI, he basically gave away how to build your own GPT for free. And so I started doing that and I did not finish it. But shout out to Andre for being awesome resource for the community. Anyway, so there is something I wanted to talk about, which is spilling from one processor to another. And I want to give a little bit of background on this and how it relates to this new NVIDIA capability here. So when we talk about pulling data into memory, which is when you use like a function like to_pandas or a similar function in Python, you are pulling data into memory, meaning you are now processing that data and holding and storing that data in your computer's RAM, like in the random access memory that your Python script is using. And this sounds low level, but I'll explain why it's relevant. Because you only have so much RAM. So if you have like a baby MacBook Air from 5 years ago, you have like a tiny, tiny little piece of RAM that you're working with. And big data is not going to play nicely with that. So what happens is you quickly are going to hit these out of memory errors if you're using something like Pandas, where the data is, again, just inflating up to 10 times because of all the metadata, the inefficient data types, the copying that Sam talked about, where the table is literally being duplicated and we're wasting memory that way. So all that to say, when you're exceeding RAM, that doesn't bode well for your data processing. And you don't even always understand like when you're wasting memory in that case. So one of the things that this NVIDIA capability does is, first of all, it's processing on the GPU, which again, it's faster and more efficient than CPUs. But we want to be able to handle the case even when there's too much data for one GPU or for the GPUs you have available. What happens then? And what we did a little bit of research into is that this rapid cuDF, it allows what we call spill from the GPU to the CPU. So when the GPU memory is overloaded, the remaining memory can still be allocated on the actual host CPU. And this is really, really cool because it's so much better than just like, oh, well, I guess I'm out of RAM. I guess we can't do anything else here. And if you try to run it again, same problem. So I think it's just a really good thing for people to be aware of that. God knows, I did not think about this early enough in my career of like, how does memory usage work? How could this be solved? And once you have that, you can really appreciate like what this tool is kind of giving you.
That's a really good point. Yeah, and then tools Pandas does not. So then there's another spill layer, right? Which is, so you have GPU, you spill to CPU, and then you can spill to disk, right? And disk access is like the slowest access. Well, other than network, IO is obviously much worse. But disk access is a layer slower than CPU or random access memory, and this CUDA does not, or cuDF does not spill to disk. And then Pandas, but Pandas also does not spill to disk, right? So Pandas, you're limited to your CPUs, and that's it, right? And then we're going to talk about some other tools later that do spill to disk, don't spill to disk, and you know, at the end of the day, you do want to. Well, do you want to spill to disk, or do you want to stream? Like, there's a lot of options, I guess, for how you want to take that. But we did want to talk about spillage as something to be aware of and something to think about.
Yeah, where it's like, understand that if you somehow need to store data because it's too big for your memory and you don't have tools like this NVIDIA bolt-on, then you are adding another layer of IO that is going to slow things down. It's going to be brittle. It's going to have undetectable errors that can occur there. Just really good to think about, how do all these systems connect? How can I connect them in the efficient way? And once you understand how it works, you can then optimize it. Again, if you don't name the problem, you can't find the solution, right? So really good for people to be aware of. And obviously this rapid cuDF bolt-on also has like zero copy, similar to what you said about Arrow. And I think we've kind of exhausted this at this point. But yeah, the really good takeaway here is it's fun to work with. And it's going to teach you about GPU acceleration without needing to learn like the low level GPU stuff that people had to do before. So you can kind of just like, again, use the familiar interface, which is the whole value here, and still be adding this additional layer of knowledge and like hardware stuff, which is pretty cool.
That's great. Yeah, I think, and we would love interaction from anyone that's maybe used this at work or used this on a project. I think we'd love to hear from people who have tried this and bolted it on. There's times when we might recommend, or at least when I could think about recommending something like this, right? And a lot of, like we were talking earlier too, a lot of times you have existing code and you don't necessarily want to take on a full rewrite with the next two tools that we're going to talk about, which would be more larger rewrites. These two kind of bolt-on approaches are a good way to really have minimal time invested and still be able to get the gains out of your code that you might be able to get. And this is when you're working in maybe like a brittle or kind of a a sensitive ecosystem where you don't want to change too many things, but you know you need to make like performance better, which actually I feel like is a lot of people. I feel like a lot of people are in a situation maybe at work or in a project where like it's working and so don't
Hmm.
touch it, right? Like if it's not broke, don't fix it. But at the same
Yeah.
time, your boss is like, we need to save money. This process takes too long. Like, how can we fix it? But your other developer counterparts are like, don't touch it. We built that 10 years ago. We don't really know how it works. And like, if you touch it, you're going to open up a whole can of worms. Right. And I feel like there's a lot of people who have either been in this situation or are in this situation now. And I feel like these bolt ons are really good to like, obviously, don't just try this in production. Like, try this somewhere where you're not going to break anything. But this could be a really good way to just add a couple commands, not really change any of the code or how any of the code works, and get much better performance. So, life hack, you'll get promoted at work and your counterparts won't hate you.
Or your money back. um Yeah, it's really good for those situations where you're between a rock and a hard place where like your team wants more speed, your team wants lower cost, but they also like we don't have the resources to go rebuild something. And so now you have a 5-minute fix and it really, really feels like cheat code. Um, but even better than a cheat code is a better system itself, right? So you can kind of polish pandas, or you can kind of just start with a better structure from the beginning. And that better structure, I think, really is the modern engine, which is polars. Obviously, kind of a reference to pandas. So you have like the panda bear, you have the polar bear, and it's really just built for speed. Like it's built to be the most efficient language rather than going, or the most efficient interface rather than going from nothing to something. We're now going from something to like a better something, which is obviously a different kind of goal that gets you to where you want to be. So I think Sam has worked a lot in Rust. And what's really cool about Polars is it's actually written in Rust. So everything that is in Python is actually a wrapper around something else, just in case you didn't know that already. And so Rust is really giving memory safety and speed in a way that Python just can't compete with. Do you want to tell us a little bit about that and some of the other wins from Polars?
Yeah, the great thing about me kind of I did the advent of code and polars, and I think that's where I really started to get into, or and not in polars, in Rust. That's where I
In
really started
Rust.
to get into like what is Rust and how does it work behind the scenes. I've been using polars for like years, right? So I thought this was great to get a look at. One thing about polars is it's the lazy execution is really powerful, and so the lazy execution, right? It'll create a plan for your query when you like run a filter operation, right? But then it won't actually run your query until you do something like a show or collect command when it actually has to return data to you, and at that time, it's then going to run the query. And a great part about that is it makes things feel faster because it'll compile, right, and it'll make sure that the code you wrote right now it works, but I'm not actually going to do it yet, right? And so that's really huge for just making for a seamless experience when you're working in a notebook or you're building a program, right? It's only going to compile and run, or it's only going to execute when it actually needs to execute. The parallelization across the CPU cores is really nice too. So again, the single threaded like GIL lock in Python when you talk about pandas, and then you have polars and you have the parallelization across the cores. So cores, you have RAM, and then you have cores, right? And so cores is talking about your ability to parallelize operations. So I know like right now, Apple's coming out with the new M5 chip, and the M5 chips have 10 CPU cores, which means you have 10 cores around which you can parallelize operations. But like
Mm.
mine, I think has like 30 or 40 or something. I don't know. I feel like the M5 is kind of throttled like right now with the amount of cores they're giving you. So that's like something important too when you're looking at specs for a new machine, whether it's Apple, whether it's Windows, whatever it is, right? When you're looking to spec out a new machine, your cores actually matter as much, if not more so, than the available RAM. So that's another thing you have to look at when you're going to spec something out. But that's another thing Polars does really well is the parallelization across the cores. And then just the API, like the API for Polars. So I came from R, actually. I started R before I started Python. And I was in the dplyr world before coming over to Pandas. And the dplyr to Pandas transition was terrible. Like dplyr felt so much just like talking and like this is what I want to do with my data, so here's how I do it, right? And I think that's one thing
Mm.
that the R ecosystem did really well. Hadley Wickham is the tidyverse author, and he did a really good job with that. But then you come over to Python and you have to use pandas, and you're like, ooh, this kind of sucks. But then Polars heard us, right? And Polars was like,
Yeah.
let's make a more pleasant API for people to use, and that's where we are today, or at least that's where a lot of people are getting today, is moving into Polars, because it's faster, it's more pleasant to work in from an API perspective, and it handles a lot of things better, like things that are larger than memory, right? Via like streaming processes. It actually doesn't spill to disk. So Polars does have GPU acceleration too. So you can use Polars with GPUs and then spill to CPU in a similar way that you can with the NVIDIA cuDF, but Polars will not spill to disk. And I'll leave you guessing for what we're going to talk about one more tool after we finish talking about Polars, and I'll leave you guessing for which one that is, and that one might spill to disk. So if we need that, you have that. But back to Polars, what else would you add to our Polar story?
Yeah, all really great stuff. And I think you just kind of unlocked memories for me of working in R for the first time, like mostly in, classes in school, and just sitting with my friend who was a math major and being like, I can literally create a linear regression model in one line of code. And like it was so easy to read that I could do it knowing nothing. Like my first day of R, I was doing that. And I think nobody's doing that in their first day of Python, probably. So yeah, just really different, very expressive, very chainable. And thinking back and connecting that to the way that people write in pandas and polars is kind of a good way of explaining this. So the way that I've seen a lot of pandas projects, and yes, I'm guilty, I've written them myself this way too, is you are basically just reassigning the data frame with every single transformation that you do. So it'll be like, df equals this, which again, don't even do that. Okay. One letter and two variable names, or one character and two character variable names are so last year. Don't do that. Don't bring that into 2026. But you have, okay, so the df is like the read CSV, right? And then the df underscore filtered, df underscore filtered underscore greater than, df underscore filtered underscore whatever splits, whatever transformations you're doing. And it's just like a lot of reassignment, and it's hard to maintain, and it's hard to remember, like if you're working in a notebook, what did I already do? And like, if I remove this, am I taking out the crucial transformation layer that I actually need? And so the reason that Polars is so expressive and readable in a way that Pandas work isn't, is because everything is chainable. So what you're typically doing in Polars, if you know how to write your transformations efficiently, is you're writing one variable that's like, let's just say data frame equals read data dot filter dot check dot transform dot filter again. And you are essentially just chaining all of these method calls, and you have one nice little thing at the end that you're going to use, again, lazily evaluated. So you're just adding to the query plan, and then executing it at the end with the collect command. So it becomes so readable. And the reason I'm highlighting this is not only because it's just so much nicer to use, but also because it is really encouraging those good practices. And when you are trying to change the way that you code, you really want to work in tools that kind of lend itself to that, tools that are going to support those positive changes. So like if you're working in a tool where the easiest way to do something is also the best way to do something, that's going to really make it easier for you to be the best programmer you can be.
Make it hard to be bad.
Yes, it's kind of like what we said in the visualization episode where we talked about you want to make a viz that is impossible to misread. And like, this is kind of making an interface that is hard to misuse. So, we always want to assume that the end users of our tools are smart, but we also want to make it hard to make a mistake. It's called a foot gun in like Bay Area software engineer speak, where you want to avoid creating things that just automatically make you shoot yourself in the foot. Like, for example, if you had the like delete kill switch button next to the run button, then someone can misclick and like delete all their code. You would never do that. That's a bad design, right? So like, just to really oversimplify this idea, you want a tool that supports your best code.
And we really feel like Polars is one of the tools that can do that, right? You have the readability, the compostability, optimizing, predicate pushdowns, projection pushdowns. So these are some of the optimization techniques within Polars that exist, right? That make it so fast and make it so performant. The predicate pushdown being filtering data as early as possible. And this is kind of built into the query plan, right? The planning time during the compilation phase before the code executes, it'll take time to figure out what are you doing, right? And then how can I do that better, right? Almost assuming that like, because Polars knows how Polars works, right? And Polars
Right.
knows the best way to run things. And Polars knows it has a limited amount of things you can actually do. There's a finite universe. So Polars takes in the operations that you say you want to do, and Polars goes, hey, I heard you, no problem, but I'm going to assume that you're like kind of dumb, and I'm going to just check behind you to make sure that like what you told me to do is like what I should actually do. Then Polars is going to go plan a different way to do that in a way that Polars thinks is more efficient and better, right? So it really doesn't matter. Like it matters, and there's a certain order you should be writing things. But at the end of the day, like Polars is going to optimize your query plan in a way that'll work better. And now that doesn't get you out of everything. There's times when like if you make really complicated plans that the query analyzer and the optimizer is not always going to work super well. And there's times when you need to like chunk that up, but really like it's not as literal, right? It's not just taking what you tell it and doing it. It's adding in some optimizations that it knows exist. So we tested that out.
Yeah.
We know that Polars is faster than Pandas for sure and works really well. And we'd say, what would you say from a learning curve experience going from Pandas to Polars? Would you say it was difficult?
I feel like, again, it's just a little bit different. It is designed to be familiar. So, like, it's really nice to have a tool that's designed for people that already know a specific tool, right? So, Polars is designed for Pandas users, which is really nice. And what that means is it's going to have like familiar data frames and operations. I would say the biggest differences are going to be like indexing. So we're mostly using filters. We're not using row indexes. There's no in-place operations, which again, so much more efficient, but it's also things are going to be immutable that you might not expect to be immutable. And again, it's very expression-based and method-based. And also just to kind of connect the dots here, and then we can move forward. But to connect the dots between like why is the expressive nature helpful to optimizing the query. So before, like I talked about, you're doing everything in pandas in one line. So I'm doing transformation 1, 2, 3, 4, 5, and they're all executing in like whatever naive, greedy way they execute. But because everything is chained in polars, like you said, the polars engine sees all the transformations in your query plan, then can optimize it all together. So like the reason it's easier to use is also the reason it's better and more optimized under the hood. And that's kind of cool to talk about as well. Yeah. So, Sam, I think the last kind of tool we wanted to talk about today is DuckDB, which I'm a big fan of. And we're a big fan of on this podcast because we're able to use it in our notebook materials for y'all. So, DuckDB features prominently in the notebook that we'll have for this episode and in the SQL notebook as well. And you haven't always had the best relationship with it. So, I think I want to talk a little bit about what DuckDB is and also some of the limitations of it, and then hear like kind of your side of the story of your journey with DuckDB. So to start people off with DuckDB, I think what really catches your eye in the data space is like the fun brand. It's kind of like the Hugging Face of data. So like in the AI space, all of the kind of logos just look like a random dot. And then you have Hugging Face, which is like kind of the GitHub for AI models. And Hugging Face is like this cute little smiling hug emoji. And so it catches your eye because it's different and fun. And so that immediately was like the first thing that I saw with DuckDB is like, oh, it doesn't take itself too seriously. It's kind of cute branding. And it makes me think this is fun and easy to use, which it completely delivers on. So like that works really well for me. So what is DuckDB actually? DuckDB is an embedded analytical database. You can think of it as like a SQLite for analytics. It's a really light way to do your analytics that is lightning fast. Why is it so fast? It's fast because it's in process. So it's not running on a separate server. It's like running within whatever other data processes that you're doing. It has that really efficient columnar storage, which means like if the word Sam is written in my column 4 times in a row, instead of writing Sam, 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 I can just write like Sam times 4. It has all of those little optimizations baked in. It's vectorized and it's also query optimized. So it has those query plans that are self-optimizing. And then something that I think isn't talked about enough with DuckDB is like when we talk about interoperability with like databases and data processes with other things, and we talk about how it's really important for your data to connect to the next piece of your operation and for everything to kind of work in a data pipeline the way that engineers do, DuckDB attaches your database or your data files with a single command. You literally just write like attach this file and make sure that it's pointing to the right place. I think that's so underrated. Like it's so nice to just be able to have something connect in one line within the database itself rather than me having to like go to Python and create a PostgreSQL cursor.
Mhm.
And then if I want to execute a query, then I have to use a string, but the string isn't safe to injection attacks. So then I have to use like pandas.sql. And then God knows I don't want to use pandas again, or I have to find some other way to write my own secure defensive way of doing that. So all that to say, you can just connect the database file in one line. And like those types of, again, one line fixes are so, so great. So a really good analogy here is like DuckDB is to Snowflake what Polars is to Databricks. It's just like a really good, easy interface for doing stuff we already do. And it also allows you to work really fast locally because DuckDB is primarily a local database. And then once you learn how to do something really quickly and efficiently locally, you can scale that to the cloud. I would say it's really good for people to know that like DuckDB by itself is not great for let's just say, corporate at scale use cases yet because you have locking issues, you have other issues that Sam might talk about. And when you use DuckDB at work, you might want to use MotherDuck or other infrastructure services that allow you to really scale to cloud operations. A shout out to MotherDuck for my Ducky shirt that I love. And I think with that, I can kind of hand it off to Sam to hear you've had some ups and downs on your journey with DuckDB. I know there's things you like, there's things you don't like. But ultimately, DuckDB is a really good choice for like SQL native analysts who want to do things in the best way. If you want to work in SQL, use DuckDB. So Sam, what do you like? What do you not like?
Well, I think the first thing about understanding like my not like for DuckDB was also me maybe not fully understanding, right, the limitations or the specific use cases of DuckDB, right? I mean, and Polars has these too. Right? These are not like it's not like one is better than the other. I think they're designed for different use cases. With the analogy of DuckDB to Snowflake and Polars to Databricks, like DuckDB is for SQL first, people that think SQL first, I believe, and then Polars is for people that think data frame first. And so
Mhm.
that's why I want to give like the Snowflake and Databricks comparison. In my experience, when I was working on just like a local DuckDB project, right, I had multiple writers to a database, and that caused like the whole thing to break, right, because you couldn't have multiple writers. You'd only have one thing, one like connection, one write enabled connection to the database at any one time. So you could only write with that connection, right? And that just didn't fit like the way I wanted to work, and so I got kind of frustrated with it. But at the end of the day, like I'm starting to come around more to DuckDB now because DuckDB like it enables so many people to do so many really great things, and like we're talking about the attaching to the database files, and also like just being able to talk to your data wherever it lives, right, wherever it lives in Snowflake, Databricks, wherever it actually, your S3 blob storage, wherever your data is actually living. DuckDB can just go back, connect to it. DuckDB also does a really good job of like reading Parquet files like from
Mhm.
your local machine, right? It just has a read Parquet function, and that actually works really well. So the fact that you can use a read Parquet function in SQL is like pretty huge. And so I think DuckDB is
Yeah.
solving a really cool problem and a really big gap. I still lean Polars, but I think I'm just understanding the limitations and where DuckDB should exist and should not exist helps you get around a lot of the problems that you might have if you just shove DuckDB somewhere where it doesn't belong. It's the same thing with Polars, right? Polars doesn't spell to
Yeah.
disk. So if you try to give a ton of data and then eagerly execute, like you're going to run into problems, right? It's the same thing with DuckDB. Like DuckDB is going to have its own problems. There's not a silver bullet for any of these tools. And that's what I've kind of started to tell myself, right? Is that it's not DuckDB, it's actually me. Like needing to better understand DuckDB. And I think around that, I think I'm definitely coming around, right? DuckDB is a great tool, and I think people should definitely spend time learning it and spend time using it, and at the same time, spend time learning and using Polars as well.
Yeah, I think that's a really good analysis of like it has its role, but that's true for all of these tools.
Yeah,
And Sam you're at this point, you're much more of like a data engineer, software engineer. Imagine if you had never looked at production Python. Like imagine how nice DuckDB feels, where you have
right.
this almost like these Pythonic functional solutions for all your problems. And just to kind of highlight how that works, when we talk about predicate pushdown in these cases, that really just means like filtering as early as possible so that we are storing and working with as little data in memory as possible. That's where the efficiency kind of comes from a lot of the time. So, like
Nice.
before, if you wanted to read data, you would have to, first of all, figure out how to read your data into your database, which is a whole separate thing, which, like, I don't even know how to do that in most databases. I'll be totally honest. Like, if you ask me, how do I do that in MySQL off the top of my head, I have to Google that. So, you'd have to, create your table, set the schema, bring in the data, figure out how to read it in. Whereas in DuckDB, you literally just say, okay, select everything from, read this file. And then you add your where clause, you add your predicate pushdown as early as possible in the read itself. And so like you can just see how this immediately aligns with good practices and makes everything easier. So if you're an analyst, like this is a no-brainer. This is literally making your life easier and better in every possible way. And then for the data engineer, they're like, well, why do I need to go back to SQL? I want to write, maybe you want to write like PySpark, and that's like the only SQL that you want to write or whatever. So I think, like you said, it really just depends how you're working and if this disrupts your existing workflow. And if it does, more power to you. Go use polars, right? So that's fine. And I think that ties right into like what we wanted to leave people with is we wanted to leave people with almost like a decision tree of like, okay, if you're in this situation, what should you do? So I think we can probably just jump into that at this point.
Yeah. So the first thing is don't reinvent the wheel. There's times when Pandas is going to be like the de facto solution. One of those times is when you're in a pre-existing spot and your data's already built, things are already built on Pandas, right? And the kind of what we are talking about earlier, you're between that rock and hard place, and like you want better performance, but you can't go back and refactor code. So in that time, like Pandas is going to be the solution. I wouldn't do a migration or a rewrite mode like 95% of the time, because you're going to lose more time in that than you are just working on, again, things that are good for the business, that make the business more money. Because at the end of the day, like the CFO and CEO don't care that the process that makes them $10 million a year, if it's built in Pandas or it's built in Polars, right? They want another process that makes them another $10 million a year. And that one you can go build in Polars or DuckDB or whatever you want to build it in. But if you spend time rewriting this service and it doesn't save you a lot of money or make you more money, right, then you're better off just not migrating or rewriting, leaving things as they are, maybe bolting on those improvements that we talked about earlier. So that's where we have the PyArrow, that's where we have the cuDF and NVIDIA process, depending on what your code is running on underneath, or what that hardware looks like. But there's other opportunities when moving forward into the future, when you're working on these new projects, that you could rewrite. And I would say, don't know if you agree with me here, like I'm sure you do, like what are your skill sets, right? Is it SQL or is it dataframes? And I mean,
Yeah.
I think if you can answer that question for me, then I can tell you exactly what tool you should use. And I think from this episode, you should also be able to pick up what we would probably recommend. If you go, yeah, we have 5 data analysts that know SQL really well and have like barely worked with Python. Well, I mean, if you go polars, I'm probably going to question your sanity a little bit, right? Like DuckDB is probably the right tool in that case. DuckDB also has other things too, like Mother Duck, Duck Lake, Iceberg support. Like there's a ton of stuff in DuckDB that like you can keep up with the new and the novel. But then if you tell me, no, my team doesn't really like using Python, or no, my team doesn't really like using SQL, my team would prefer to use Python, I'm going to shout out to our AI and safety episode. That should be coming out soon. For someone in that episode doesn't really love SQL, spoiler.
Spoilers.
And if that's the case, you should probably be looking at polars as a solution for a future rewrite. So what would you add to all of this?
Yeah, I think that's exactly spot on. Can you tell that we're aligned on most things? No, but yeah, it's exactly spot on. It's again just understanding that like data strategy does not mean buying a bunch of tools and throwing them at your team and saying, "Hey, this is what we're doing." Data strategy means like, okay, what does the business need? Who are the analysts and engineers and data scientists that need to work on this stuff? What is their profile? What do they like? And if you're a leader who really understands your team and understands the space, then it's not what is the best new tool. It's like, what is the best tool for your team? And sometimes that's a free tool that you already have. And now you save money. So good for you. But yeah, so really just understanding the use case like we would for anything else, right? I think in this AI bubble that we're seeing, everyone's kind of asking, how can we add AI onto this thing? Rather than asking like, okay, where can AI actually drive more value? And what thing is better as a regex, right? So that's kind of the practical approach that we're taking here of like, where does it drive value to use these tools and understand the profiles where that kind of drives value. I think it would be good to nod a little bit toward the accompanying notebook for this episode, which I think Sam is going to talk us through. But we really wanted to put these tools to the test and look at a notebook that essentially runs the same large data analysis, big data analysis on each of these tools, being Pandas with PyArrow, then also polars, and then also DuckDB, and seeing what does that memory usage actually look like So stay tuned for that accompanying notebook that I just wanted to kind of shout out here, where we're actually going to look at the efficiency of these tools side by side on the same work, because you can see like really high, 90+% cost reductions here. But we wanted to really show people that in action to show why it's worth kind of looking at things this way.
Exactly. And what would we add to anyone listening to this episode who's kind of within that 5 years of just getting out of grad school? I think this is when or undergrad, and you're kind of working in this like analytics, data science space. Like your code needs to run faster, but you don't know necessarily how to bring it up. And I would say this is a spot where like I've done well sometimes and I've not done well other times. And I would say what we're leaning into in this episode is trying to help you like be pragmatic about how you approach improvements in your work, right? So for me, it was a lot of like pet projects, and still is a lot of pet projects using these tools, right? And I think that way I just have a better understanding of what they are and how they work. Because obviously, I don't want to go up to my boss and be like, "Hey, we should use this tool," and he goes, "Well, what is it?" And then I stutter over my words trying to explain to him like what this thing is. Like I need to have a good reason why we want to do something, and why is what, again, keeping in mind the implications of what this means for my team and how much time they would have to invest in a process like this around this is worth it for the business. It's going to cost us X amount of money because it's going to take this much time to do some sort of migration, but it's going to save us Y amount of money after 6 months to a year, again, depending on the project. I think you just have to like I still get excited about tools, and I think we should get excited about new tools and new things and technologies that are coming up that make our work easier and more interesting. And at the same time, we have to acknowledge that it's not always the right path forward. So I hope that's kind of been clear in this episode. But at the same time, like get excited. Like go play with these things, go learn about them, go be able to talk about them and share them with your colleagues. Because at the end of the day, also like if they don't know about it, then they can't even accept whether they're going to take on a migration project or not. Like maybe the migration project is worth it. So I don't want to kind of steer you away from that either. It's just be pragmatic about how we approach these things at work.
Yeah, and I think it comes back to getting to that senior mindset and just writing better code in general. It's about knowing which advice is good advice and knowing which shiny new tool is actually worth using. So, like, having the skills to evaluate tools is really, really important to everything that you do, and especially as you move into like more data leadership and ownership. Um, and so, if we can kind of zoom out back to, how do you write better code in general? And how do you think about that? The biggest tip that I've ever heard for this is actually something that my fiance taught me like many years ago. He's an amazing engineer. And the first thing that he taught me was future you is a different person. And if you're not going to understand this a year from now, nobody else is. Think about kind of that. And it helps that I have like kind of a goldfish memory. So it's very easy for me to like understand this and document every single thing. Cause if I don't, I'm not gonna get through. But if future you is a different person, then think about what would you need to look at this code with no context and understand what's going on. And also just be able to make it just work. Like it shouldn't be using a full file path where the file can just move around. And it shouldn't be a system that like we have a free trial on, but we're not going to have it in 5 years. Like just all these things. It's a really helpful lens for these different kinds of considerations. And then also collaborating more so that you kind of take this out of theory and into practice where it's not just that future you is a different person. It's that like Sam needs to understand this code right now and be able to like look it over at my desk and understand what's going on. And when you collaborate more, you are forced to communicate better. Just like if you do a lot of public speaking, you're forced to get better. It's the same thing, right? You're learning how to communicate in a new way. And the last thing is forcing yourself to use formatters and Git in your independent projects and in all of your work. Because again, you are building this practice and this experience of like, okay, well, Git has to like it, so I have to write clean changes. And I don't remember what I did, so I have to write good commit messages, or AI has to write good commit messages. Let's be real, it's 2026. And again, future use a different person. So have the code auto formatted nicely instead of trying to remember that you like always enter when you have 3 lines or more. Just let the formatter do it. And so like it's a mix of kind of forcing yourself to be in these situations where it's valuable to be good. And then also automating that away because you need to focus on features and you need to focus on business impact. Anything you want to add to that, Sam?
One thing. I
One
thought those
thing.
were all really good points, and I've benefited from all of them at one point or another. And while you were talking about them, I remembered back to the times when that bullet point was important for me. And so one that it brought up for me is when you comment your code, it's why. not what.
Mm.
I'll comment the why. I can read your code, I hopefully, and understand what you were doing. But why did you do that? Like, what prompted you to need to create this? Ideally, you created a function or a class or a function within a class. And like, why? What situation brought this up that it was important to now have this? Right. I think if you take that on, it's going to help you in the future. I also have goldfish memory. It's going to help your teammates too in that collaboration space. So you'll save a lot of headaches if you think about your comments as why and not what.
I think that's such a good call out, especially in the AI era where people's AI code is so obvious because the comments are full of like, this answers the question that you asked me in chat.
Yeah.
Like the AI commenting that it answers a specific ephemeral question, or like it'll be df.filter and it will say filters data. And it's so unhelpful and duplicative and literally just adding like 100 lines to the diff for no reason. So I think taking this approach, it's not only great for your team and your code, it's also good for your own comprehension to like
Mhm.
genuinely stay sharp in this age of AI, where if your comments are actually meaningful and they're telling you why you made a specific decision because of this other constraint, because of this system that it has to connect to, or because like marketing is using this regex, so it has to match this pattern or whatever, that kind of overall understanding is going to, I'm not going to say AI proof your career, but I'm going to say like it's going to help you make sure that you know what's going on in the age of AI and that you are adding human value on top of that.
Exactly. Yep. And all these points I think drive home. I think the why instead of the what also like drives home a lot of the points, right? Future use a different person,
Yeah.
collaborate more. It's like, okay, big part of this is why did I write this code? So thanks for sticking through with us. Hope we've dropped some wisdom on you. Have a great rest of your Saturday. Again, this has been Sam and Schiff with the polars versus pandas versus DuckDB versus anything else versus spaghetti code and how to write better code and knowing when to migrate. But again, hope you enjoyed this episode as much as we did. I know we had a lot of fun sharing and talking about the things on here. So until next time, this has been Sam and Schiff with Saturdata.